Hello and welcome to Prepspot. In this video, we are going to know about a groundbreaking development in India's space technology sector, a development that highlights the country's growing capabilities in nuclear-powered space technology. On 1st March 2025, two Hyderabad-based startups, Space Nuke Technologies and Astropower Solutions, made a significant announcement that they will soon test nuclear-powered modules in space. This initiative is not just about technological innovation. It reflects India's ambition to provide reliable, long-lasting power sources for deep space missions, which is essential as we push the boundaries of space exploration. To provide you with a comprehensive understanding, let's start with some background and context. As you know, India's space program, led by the Indian Space Research Organization, ISRO, has achieved remarkable milestones over the years. We have witnessed Chandrayaan-3's successful lunar landing in 2023 and Mangalyaaan's orbit around Mars in 2014, among other achievements. Yet, as ambitious as these missions are, they still depend largely on solar energy, which poses significant challenges for deep space missions where sunlight is scarce or completely unavailable. This is where nuclear-powered modules, specifically those based on radioisotope thermoelectric generators or RTGs, come into play. RTGs convert the heat released by the radioactive decay of isotopes like plutonium-238 into electricity, and this technology has been successfully employed by NASA on missions such as Voyager, Cassini, and Curiosity. Now, why are these new tests by the Hyderabad startups such a big deal? For one, they represent the first time that Indian startups have taken the lead in developing and testing nuclear-powered modules for space applications. This initiative is part of a broader push towards self-reliance in space technology under the Make in India campaign, which was launched in 2014. Hyderabad, in particular, has emerged as a prominent tech hub with a growing number of startups focusing on space technology, over 50 such firms, according to Invest India's data. These startups are not just small players, they are at the forefront of innovative energy solutions for space exploration. Their work is expected to pave the way for reliable power supplies for deep space missions, which are crucial for long-duration missions where solar power might not be a feasible option. The announcement itself was made at a press conference in Hyderabad on 1st March 2025 at 10 a.m. Indian Standard Time, and it immediately drew widespread media attention. Outlets such as The Hindu and Economic Times reported extensively on the potential economic benefits and the job creation that this initiative could bring. For example, industry estimates suggest that each nuclear-powered module could produce around 500 watts of power, and the startups have estimated the cost per module to be around 100 crore rupees, with a total investment of 200 crore rupees for the project. Additionally, this initiative could create about 1,000 new jobs by 2026, providing a significant boost to the local economy and reinforcing Hyderabad's reputation as a growing tech hub. Let's talk a bit about the technical aspects. The modules in question are likely to be RTGs, devices that convert the heat from the radioactive decay of plutonium-238 into electricity. This method of power generation is especially useful in environments where solar power is limited, such as in deep space or on planetary surfaces far from the sun. The design of these modules is quite sophisticated. They are compact, incorporate multiple layers of containment to ensure that there is no radioactive leakage, and are equipped with advanced cooling systems and radiation shielding to protect sensitive components. The testing process for these modules is also rigorous. The startups plan to launch these modules using ISRO's PSLV, attaching them to satellites for in-space tests, and the performance will be closely monitored by ISRO's Telemetry, Tracking and Command Network, also known as ISTRAC. This network is critical in providing real-time data on the performance of the modules, ensuring that any anomalies can be addressed immediately. The origins of this project are quite interesting as well. Both Space Nuke Technologies and Astropower Solutions were founded in 2020 at Hyderabad's T-Hub, which is recognized as India's largest innovation hub. Dr. Ramesh Kumar, a nuclear physicist with a PhD from IIT Bombay, founded Space Nuke Technologies, while Astropower Solutions was founded by Ms. Priya Sharma, an aerospace engineer from IISc Bangalore. Their journey began with feasibility studies in 2022, which indicated that nuclear-powered modules could indeed offer a viable solution for deep space power needs. These startups have also received support from established organizations such as ISRO and the Department of Atomic Energy, which has further bolstered their research and development efforts. It's important to understand the broader implications of this initiative. On one level, the successful testing and subsequent deployment of nuclear-powered modules could revolutionize space exploration by providing a reliable and continuous power source for missions that venture far beyond Earth's orbit. This is crucial for deep space missions where solar panels might fail to provide sufficient energy. Moreover, by relying on nuclear power, these missions could have longer operational lifespans, potentially reducing the need for costly and frequent resupply missions, which would be a significant advantage in terms of both logistics and economics. Economically, the initiative could have a substantial impact on India's space sector. With the global space market valued at around $400 billion by 2025, according to Space News, innovations like these not only strengthen India's position in the global arena but also have the potential to generate export opportunities and foster international collaborations. The economic benefits are not limited to the space industry alone. The development and testing of such high-tech modules could spur advancements in related sectors, such as nuclear technology, materials science, and even robotics and automation. This, in turn, could lead to the creation of high-skilled jobs and contribute to the overall growth of India's digital and technological economy. From a societal perspective, projects like these help build national pride and inspire a new generation of scientists and engineers. When students see their country taking bold steps in space technology, it motivates them to pursue careers in STEM fields, thereby contributing to a more robust and innovative workforce. Furthermore, the initiative underscores the importance of self-reliance in technology, a key objective of the Make in India campaign, and demonstrates that Indian startups are capable of developing cutting-edge technologies that can compete on a global scale. Of course, as with any ambitious technological initiative, there are challenges and concerns that need to be addressed. Safety is paramount when dealing with nuclear-powered modules, especially in space. The use of radioactive materials like plutonium-238 necessitates stringent safety protocols to ensure that there is no risk of contamination or accidental release of radiation, both in space and in the event of a re-entry or launch failure. The startups and the supporting agencies have assured that all necessary safety measures have been incorporated into the design of the modules, including multiple layers of containment and advanced radiation shielding. However, these assurances will have to be continuously monitored during the testing phase and beyond. Another challenge is the cost. With an estimated investment of 200 crore rupees for the initial project and the potential for each module to cost 100 crore rupees, there is a significant financial outlay required. Yet, when you compare this with the potential benefits of having a reliable power source for deep space missions, the cost may well be justified. The economic returns could be substantial, not only in terms of the success of future space missions but also in terms of the export potential of the technology. Additionally, the job creation prospects, estimated at around 1,000 jobs by 2026, add another layer of economic benefit to the project. There is also the regulatory and technical collaboration aspect to consider. These startups are operating in a highly regulated environment where close coordination with established organizations such as ISRO and the Department of Atomic Energy is critical. The integration of nuclear technology into space applications is not a trivial task, and it requires adherence to strict international standards. The successful testing of these modules could pave the way for more such collaborations, enhancing India's overall capabilities in the space sector and positioning the country as a leader in innovative energy solutions for space exploration. Looking at the global context, this initiative reflects broader trends in space exploration. As traditional energy sources become less viable for deep space missions, the use of nuclear power, particularly through RTGs, has become increasingly important. NASA's Voyager and Cassini missions have relied on RTGs for decades, and many countries are now exploring similar technologies. India's entry into this field through its Hyderabad startups not only aligns with these global trends but also reinforces its commitment to developing indigenous technologies that can contribute to sustainable space exploration. In conclusion, the announcement by Space Nuke Technologies and Astropower Solutions to test nuclear-powered modules in space represents a major step forward for India's space technology sector. It encapsulates the innovative spirit of the country and underscores Hyderabad's emerging role as a technology hub. With a planned test date in June 2025, daily testing operations scheduled from 9 a.m. to 5 p.m. Indian Standard Time, and a potential for significant economic and scientific benefits, this initiative is set to redefine the way India approaches deep space missions. While there are undeniable challenges, ranging from safety and cost to regulatory compliance, the potential benefits in terms of job creation, export opportunities, and technological self-reliance are immense. As we continue to push the boundaries of what is possible in space, developments like these not only inspire a new generation of scientists and engineers but also contribute to a future where clean, reliable energy powers our exploration of the cosmos. Answer this question in comments. The correct answer will be given hot and pinned. Lastly, we just want to let you know that we are a newly emerging online platform for competitive exams. Creating educational explainer videos like these requires a lot of effort, money, and time. If you like these videos and want us to excel and create videos in all categories of competitive exams, then you can consider supporting us with a one-time donation through the Ko-fi platform and also by becoming a member through Patreon. This will help us create more such informative educational videos in the competitive exams space. So, one last time, subscribe and share this channel with all your friends who are preparing for competitive exams. And also, follow us on social media platforms. The links are given in the About section of the channel and also in the video description. So, see you in the next video.